Okay, example 3 asks you to use your calculator. So pause the video and get 3x squared minus 8x plus 2 into your calculator. Okay, so then it says to identify the intercepts using your calculator. So if you look at your calculator, I want you to notice how those intercepts don't look like they're right at a number on the grid. Okay, so we've done this a lot to find maxes and mins. You hit second, and then you hit calculate. Okay, and when we do that, we always picked max and min is what we were doing. I want you to try something new. You can also hit, this time I want you to hit 0. Okay, and when you hit 0, you are finding the x-intercept. So you're going to have to do this process twice. When you hit 0, it does that same left bound, right bound thing. So you move your cursor left bound, hit enter, right bound, hit enter. It asks for a guess. You have to hit enter a third time to actually get your zeros. So I want you to pause the video and try that. Okay, you should get approximately, the first one is at 0.279. I don't know why I'm rounding to 3 decimal places. That's just what I have in my notes. And then you have to do it a whole nother time, 2.387. Okay, so that's another thing that your calculator can calculate. Okay, then the other thing, state intervals of increasing and decreasing. That means you need to find, this one has a minimum. Where is that minimum at? So if you find that minimum, go ahead, pause the video, go find that min. You should get 1.33, comma, negative 3.33. Okay, so that means it starts off decreasing. So it's decreasing. Now, when you're talking about increasing and decreasing, you just talk about the x value. So it's decreasing on the left side. So when x is less than 1.33, and then it's increasing on the other side when x is greater than 1.33. Now, a lot of you are still writing, and this is fine, but a lot of you are probably wondering why I'm not writing this in red. You don't have to write that with an inequality. By just saying that x is less than 1.33, that also implies that it is greater than negative infinity. We don't usually write that with inequalities. Okay, moving on. This is the back, no, it's not even the back page of the notes yet. Okay, so lots to review with quadratics. This time it's asking to graph by finding the vertex and plotting 4 other points. So the vertex is x equals negative b over 2a. So in this case, it's negative 6 over 2 times 3, which would be negative 1. So then you have to plug in negative 1. So that is literally 3 times negative 1 squared plus 6 times negative 1 plus 1, which gives you negative 2. Okay, so this is probably the first way you learn to graph a parabola. So by building a table. So I always encourage my students to put that vertex kind of in the middle of the table. And then since quadratics are symmetric, when I pick a number more than negative 1, 0, that's 1 away from negative 1. What's also 1 away from negative 1? Negative 2. It ends up being BOGO. You should get the same value whichever one you plug in. And obviously 0 is way easier to plug in, so I'm going to pick 0. You plug in 0, you get 1. Well, guess what? You'd also get 1 if you plugged in negative 2, because they're symmetric around that axis of symmetry for that parabola. Okay, so then you pick 1 and negative 3. Also BOGO. They're each 2 units away from the vertex, so they should have the same output of 10. Okay, I'm not going to actually take the time to, because I know you can plot points, then you would plot those 5 points on a grid. Okay. This example, I basically, again, this is very, very much review. You guys are very lucky that a lot of what we're doing when we're not together for the rest of the year is a lot of review. So this example is just saying, find the max and the min of the function using algebra and using your calculator. What I'm pretty confident is that you can use your calculator. We did just practice that in a previous example. But a big light bulb moment you need to have is that the max or the min is the vertex, right? The max or min of a parabola, of a quadratic, is the vertex. So this one is going to have a minimum. How do I know that? Well, it opens like this since a is positive. A equals 1, so it's going to open up. If it was negative x squared, then it would open down. So it would have a max. But this one has a min. So you would do x equals negative 4 over 2 times 1 and get 2. Go ahead and pause the video and get the y value. You should get negative 9. And then you should be able to verify that on your calculator. Okay, a word problem then with maxes and mins. The John Deere company has found that revenue in dollars of heavy-duty tractors is a function of the unit price that it charges. And there's a formula for the revenue. What unit price should be charged in order to maximize revenue? Well, this parabola, since it is negative, and since it doesn't have a constant, I know that it goes through, I know that it's going to have a y and x-intercept at 0. It's going to look something like this. And this vertex is going to be the maximum, and that's the value p that maximizes r. So that value p is negative b over 2 times a and you end up getting 1900. So this is the price. This is like the perfect price, right? That they get enough people to buy it. Okay, so this is where people often miss points. They stop here. That is only the price. That only answers the first question. But then I also have the second question. Hey, by the way, what is the max revenue? Well, that's R of 1900, which is also money, and that ends up being 1,805,000 is the revenue they're going to have when they sell it at that price. Okay, 2 more examples, and they're shorter. So I give another quadratic here, and I ask for a few things. I first ask for part A. I want to know when f of x, oh, it's right there, equals 0. So that means you're setting this equal to 0 and solving. We have done this so much this year, guys. I've been forcing you to learn how to guess and check, not use that table method. I'm hoping you're getting better at that, factoring this. So I know this has to be x, this has to be x, and then what am I going to have here and here and here so that they multiply in L, in FOIL, to be -8, but then they add to be 2. So if it's +4 and then -2, that should work out. Okay, so then if you're solving, this time it is actually asking to solve, so you would do the ZPP, and ZPP would give you x equals -4 and x equals 2. Now, part B says, okay, what about if f of x equals -8? So you set it equal to -8. We've also done stuff like this year. Because what you first have to do is, in order to factor, you have to set it equal to 0. So you're going to add 8 to both sides. When you do that, you end up just getting 0 plus x squared plus 2x. Okay, and then when you just have the quadratic and the linear term, you can factor with a GCF. Okay, so when is the y value -8 by the ZPP? When x is 0 and when x is -2. Okay, last example. Okay, solve this quadratic. So what you might do is you might start guessing and checking here. So you need x, and then you need factors of 5 that sum to be 4. Okay, so you've got 5 and 1 to work with. If it was 5 and -1, you would get 4 when you added them together. But what is 5 times -1? -5, and this is a +5. This one does not factor. And that's when you have to resort to the quadratic formula. Okay, so you'd get -4 plus or minus the square root of -4 all over 2. Well, the square root of 4 is 2. What is the square root of a negative? I. Okay, and then actually that does simplify too. Alrighty, so then the question is, what does this tell you about the graph? Well, it tells you this graph does not cross the x-axis because there's no real solution. Alrighty, your homework, this is the last thing you have to do, and then you have a long break. So if you could even get this done Tuesday and then have nothing to do Wednesday. So this homework is what I'm assigning, and it needs to be turned in on PowerSchool Learning, and then your Easter break starts.